Hey everyone! Today, I'm going to help you understand electric current. We'll dive into what it is, how it works, and why it matters. Ready? Let's go! First off, electric current is all about the movement of electric charge carriers. Think of these carriers as tiny particles zipping around. We've got electrons, which are negatively charged, and protons, which are positively charged. Sometimes we also deal with ions. These are atoms that have either lost or gained electrons. And then there are holes, which are basically spots where an electron is missing, making them positively charged. Now let's talk wire. In a wire, the electric current is essentially a bunch of electrons moving through it. Imagine you're watching a parade, and you count how many floats pass by in a minute. That's kind of like measuring electric current. It's the amount of charge passing a point in the wire per second. We have two main types of current: direct current, or DC, and alternating current, or AC. In DC, the electric charges flow in one direction. Picture a river flowing steadily downstream. In AC, the charges switch directions periodically. It's like a tide going in and out. Here's a bit of a twist. In many electric circuits, we talk about current moving in the direction of positive charge flow. This is called conventional current. Even though electrons, which are negatively charged, are actually moving in the opposite direction. Kind of confusing, right? But stick with me. When it comes to gases and liquids, things get even more interesting. Positive ions move one way, while negative ions move the opposite way. But overall, we still consider the direction of positive charge flow as the direction of current. This helps us simplify the math and make sense of things. In semiconductors, we have holes moving one way and electrons moving the opposite way. But again, we usually focus on the conventional direction, which is the direction of the holes. Electric currents aren't just limited to wires. We see them in particle accelerators, with beams of protons, positrons, and other charged particles zooming around. These currents generate magnetic fields, which are super important in things like electromagnets and electric motors. And here's a cool fact. When an electric current flows through a conductor, it generates heat. The amount of heat is proportional to the square of the current, so more current means more heat. Finally, let's talk units. The standard unit of electric current is the ampere, or amp for short. 1 ampere is the flow of 1 coulomb of charge per second. Think of it like counting how many coins pass through a toll booth every second. So there you go. Electric current in a nutshell. From electrons to amperes, now you've got a solid understanding of how it all works. Thanks for watching, and I'll see you in the next video.